Okay, that was the first sentence. My ride has hydraulics. Remember, anions that end in IDE are going to be named using hydro and ig. The next sentence was I ate something icky. I ate something icky. That means that if the anion ends in ATE, the name, the acid's name is going to end in ig. And the other sentence from the mnemonics was Sprite is delicious. That means that if my anion ends in ITE, it's going to be replaced by the suffix "-ose". Okay? Remember. So this is what we know as the ending. If you have that ending, replace it by what you had in the right. So let's take a look to these three examples from here. The number 1, okay? The number 1, this one. P. How do you name P? Remember the table that Taylor shared in the video. How do you call P?
Phosphide.
Okay, P can be, it is phosphide. Okay, remember, what I do in the first place, I check the ions. Okay, this is what I do in the first place. I know I can do it mentally, but I check the ions to be sure. Okay, so the ions for acid, they always have H plus. Always H plus. Okay, now what is the ion? Okay, this ion right here, P. What is the charge that P has?
-3.
-3. This ion has a name. The element is phosphorus, but the ion's name is phosphide. Now, what rule from the mnemonics are you gonna follow for this exercise? Is it the 1, the 2, or the 3?
1.
Okay, so we're talking about my ride has hydraulics. My element, my ion ends in IDE, which means that I'm gonna apply this one. My ride has hydraulics. So the name will include the prefix hydro. The name will be hydroic acid. Remember, what happened with phosphorus? Phosphorus is also important because it has an exception of the rule, okay? The special root for phosphorus that I gave you, remember the special root that I gave you for phosphorus. For phosphorus, the root that we use is phosphor, okay? Phosphor, okay? So it is phosphoric acid. hydrophosphoric acid. For the second example, I have the ions H plus and the rest of my acid, that is PO3. Now, what ion is PO3? What charge does it have?
Phosphide.
The name is phosphide, and what charge does it have? It is also -3. So take a look here. The ion ends in ITE. What rule should I follow? My right hydraulics, I ate something icky, or Sprite is delicious.
Sprite is delicious.
Sprite is delicious, okay? So it means that we need to follow the rule number 3. Sprite is delicious. So you're going to replace ITE by O's. So the name is going to be the special root for phosphor, that is phosphor, and then the suffix. Instead of ITE from Sprite, you're gonna write delicious, O's, phosphorus, and then the word acid. And what about the number 3? What ion is that? That is PO4. What
It
is the
is
name?
phosphate.
It is phosphate. Phosphate. And what is the charge of phosphate?
-3.
Also -3. Okay? So it ends in ATE. Therefore, what is the mnemonics that you're going to follow? 8. Phosphate 8. I ate something icky. Okay, so you write the special root for phosphorus, that is phosphor, and then the special suffix. I ate something icky. So, phosphoric, and then the word acid. 3 ways to name very similar acids by the name, but the formulas are different. So when I tell you that you need to send me your procedure to classroom, I meant this. Yes, I know that many of you can do this mentally. But me as a teacher, that's what I check, the procedure, okay, that you analyze like this. Remember, IDE, hydraulics, ITE, Sprite, ATE, icky, okay? So, remember this, you're gonna be just fine if you never forget to use the mnemonics. The mnemonics tells you exactly what to do. Is there another doubt that you have from acids? Okay. So a student from the other section asked me about wait. Okay, another student from the other section asked me about oxalic acid. Okay, she asked me, Miss, how can we do if they give us the name oxalic acid. So take a look for this case. Oxalic acid. So I'm giving you the name and I'm asking you for the formula, okay? That's how it works. Or I give you the formula and I ask you for the name. So in this case, I'm giving you the name and asking for the formula. So how to work with acids? First of all, the first key that is an acid is the word acid, even though it's pretty obvious. That tells you that it is an acid. So what I do is whenever I see the word acid, I replace by the ion H+, because all acids have hydrogen. Now, I focus on this word, oxalic, okay? So I'm going to work with this apart. Oxalic. So, from the rules, from the mnemonics, oxalic ends in IC. Oxalic, okay? If it ends in IC, now we're going backwards. If it ends in IC, it can either be my right has hydraulics or I ate something icky. But here oxalic doesn't have the prefix hydro. Therefore, I'm just going to get using I ate something icky. Oxalic ends in IC. So that means that the polyatomic name originally ends in ATE. So I'm going backwards. I'm going to get rid of the ick, and I will be replacing it by ATE. Okay, so this gives me in the end the name oxalate. Once you have oxalate, you look for the polyatomic ion, okay? What polyatomic is this? To know what polyatomic it belongs, you need to look for the tables. Take a look. Look for oxalate. Oxalate is located right here. The formula for oxalate is C2O4 and the charge is -2. So, in the end, the oxalate ion is C2O4 and the charge -2. So, this is an acid. You need to put the positive ion in front. So it is an acid that is combined with H+ and C2O4. So when you mix them, you apply the rule for combining ions. These two from here, it's going to come to the other ion, okay? So the -2 from oxalate, you put it here. And this gives you the formula for the acid, oxalic acid. So this is how you work from the name to obtain the formula. Step-by-step process. The word acid tells me that it has hydrogen in the left side, and oxalic tells me, because it ends in ick, I ate something icky. So the real name is oxalate, which is a polyatomic ion that has this composition, C2O4 and -2. Remember that when we have to combine charges, when we need to combine ions, we need to crisscross the charges. But we only crisscross the charges that are different than one. So this one, the first one, can be totally ignored. So in the end, you're only moving one charge. That is a true negative. And remember, when you write it down, you don't write the sign, just the number. That's how you obtain the formula. Is there another exercise that you want me to analyze? Bueno. Okay. One student 2 years ago asked me about this. I like to include my students' questions in my explanations because I know that it could be a question that any other person could have. And I especially love this one because I never thought about it before. And this question was made by Adalid, Miss Mejia's son, okay? He asked me what I consider to be the most shocking question in naming acids. And it is, Miss, he asked me, Miss, how can we do if we need to form an acid from hydrogen and cyanide? That's what he asked me. So for them, I gave them the rule that if you have binary elements, you have to use hydraulics. And if you have more than 2 elements, you have to use the prefix changing, like from ITE to O's and from ATE to IC. Okay? So CN doesn't correspond to any of those. What is CN? Going to that day that he asked me, I couldn't answer, honestly, because I never done this exercise before he asked me that. So I didn't know what to answer, and I was analyzing and I couldn't give him an answer. Okay? So we follow the rule. Remember what Tyler in the video said. We're gonna have 2 types of acids. We're gonna have acids without oxygen and acids with oxygen. Xavier.
I think that CN is cyanide, I think.
It is written cyanide and it's pronounced cyanide.
Okay.
It is
But I think that
written
is
cyanide. Very good. That's the name. Now, do you see oxygen in that composition?
No.
So the name is cyanide and you have no oxygen. So what is the rule that we need to follow? From the mnemonics. The name is cyanide. It ends in IDE. What is the mnemonics that we need to follow? 1, 2, or 3?
1.
The 1. The number 1. It says my rice has hydraulics. So in this case, for cyanide, even though it's not binary, the rule for binary acids apply to it because it doesn't have oxygen and it ends in IDE. So no oxygen and cyanide, okay? Cyanide, so remember, my right has hydraulics. So the name will be hydro, and then the word acid. And we're gonna put between hydro and ic is going to be the root for cyanide. That is going to be everything without the IDE. So the name in the end will be cyanic hydrocyanic acid. Now, in your textbook, I want that you open your textbook on the page 211 and tell me what is the topic that it appears over there.
Here it says naming binary ionic compounds.
Naming binary ionic. So in the page 211, you have to do the practice for binary ionic. Why? Because in the next quiz, it's most likely that I evaluate all the topics at the same time, which means that you need to review all of it. So I want you to begin by practicing with the pages that I'm going to mention today. Yes, I will be evaluating acids, but also mixing all the topics. So in the page 211, you're going to find binary ionic. In the page 212, what is the topic over there? What is the topic over there? Take a look at the example in the page 212. It says, name of the compound, copper 2 chloride. What kind of naming is that? Why is the book using Roman numerals? What kind of element is copper?
It's a transition metal.
So, in the page 212, it is still the topic binary ionic, but using Roman numerals. Now, why are we using Roman numerals? Because we're using transition metals with multiple charges. That's the reason. Even though it is binary ionic, here we need to be using the Roman numerals. The Roman numerals is the same stack system, okay? And why we use that? Because we have transition metals that have multiple charges. Now, in the page 214 is the next page, okay? Page 214. What topic is this?
Elements that form more than two Element.
Okay, elements that form more than two oxyanions. The oxyanions are the same polyatomic. Okay, so the topic for the page 214 is ionic polyatomic, but also includes the topic ionic polyatomic for transition metals. Because you can see that some exercises include Roman numerals, okay? So the topics are two in this page, ionic polyatomic and ionic polyatomic using Roman numerals. For transition metals. With multiple charges. So here you have one topic and here you have two topics, okay? Here is one topic. Now in page 215, what topic is that? What topic is that?
Perfect system.
Binary covalent compounds.
Binary covalent compounds or binary molecular compounds is the same. So here is binary covalent or molecular compounds. Also known as the prefix system. It's the one that uses the prefixes di, tri, tetra, penta, hexa, hepta, like that. Okay? So this is the topic, and that's the page where you can practice that topic over there. And then in the page 218, you have a review. That review is mixing all the topics. But also, if you take a look in the part 5, it shows this kind of exercises. In the part 5, you can find a few acids. So, work on those pages, okay? Remember to do all your work, all the procedure, showing the ions, positive and negative ions, and showing the name or the formula. Forming the compounds, so you need to form the formula. And please, this is going to help you to study for the quiz that we're going to have, where we're going to mix all the topics. If you have any doubt on those pages, you can ask me. Now, from all those topics, what is your favorite topic? What is your favorite topic? None. Okay. According to my experience, students tend to like this one right here. That's the one the students prefer. Using the prefixes diphosphorus, pentoxide, like that. They love to use it. Under my experience, it is like that. Now, I hate it. I totally hate it. Okay? You can respect me or not for hating it, but there's a reason why I hate it. The reason is, once the student learn this system, they want to apply it to every single compound, and it's not like that. Okay? So it has to do to the type of compound that you have. If you have covalent compound, you can apply it. If not, it will be wrong. For example, take a look to this one right here. How would you call this compound? How would you call that compound? How many elements do we have here?
Well, the
Two.
iron, the
We have
oxide,
how? Sorry?
the iron oxide,
Exactly. Exactly. This is what I want to avoid from you. That's why I hate this topic. Because when you learn how to call binary covalent, you want to apply it at every single compound. Now, this is not covalent. Okay? This is not covalent compound. It is ionic. And ionic compounds don't have prefixes. So the right name to name it is not triiron trioxide. That is always one of my choice, because I know that is a common mistake. But trust me when I say common, very common. So it is ionic binary for a transition metal. The name for this one is iron 3 oxide. Like that. Why? Because it is ionic. So the first question that you need to answer mentally is what kind of compound I have. Is it ionic or is it covalent? Only if it's covalent, you can use the prefixes. If not, you use the same method that I explained from the beginning. So